Hello everybody and welcome to episode 3 of my Unity Minesweeper tutorial. In the last two episodes we covered just player interaction and we created a tile script. This time we'll be worrying more about the our board class, which will be handling the generation of the tiles as well as some other game management features. I'm debating whether to make a board class that I'll basically take care of everything, or to make a game manager class, but I'm most likely going to be sticking with a board class for simplicity. So the first thing we're going to do, if we just jump right into it, is I'm going to go to our scripts folder, right click, create C# script as we have for our other two scripts, and just go ahead and press enter after naming it, and just wait for the compilation. Alright, so we are now in our script. So the first thing we want to think about is what we actually want to do. So our board class is going to handle the instantiation of our tile object. Remember that we had our tile prefab here, so we can freely instantiate this as we need. But how do we do that though? So we actually need a reference to our tile prefab. So just so you can delete all this boilerplate code. And so we're actually going to create a reference to a game object. So we do a private game object and tile. And to be able to reference a prefab, we actually need to serialize this. So it's accessible in the inspector. And we can do that. We press save. And just Control S. And if we go back to our Unity project, we actually need to put our script on something. So for now, I'll just create a board object. Transform, and then just add the board script to it. And you can see here we actually have a empty reference to a game object in our inspector, and here we can actually just drag in our tile prefab. Or you can go in here and just, well, there you go. You can see that. Also, if you're getting some of these other assets, you can just click this and it'll hide. At least most of them. I believe these are just Unity prefabs or development ones. So anyways, now that we have our tile reference, we can actually get started with instantiating our tiles. But before we do that, we actually want to keep track of the width and the height of the board, as well as mine count, because remember that our board is going to be a grid of tiles, and obviously we want to know what the size of that board is going to be so we can instantiate our tiles correctly, as well as the mine count. So what I'm going to do for that, we're going to create 3 int variables to keep track of the width, height, and the mine count that we have. So we're going to create a private int variable, name this width, and by default to set it to 10. And then I'll do height, and then mine amount, or you can put count, doesn't really matter. And then by default, for 10 by 10 board, I'll just do 10. Alright, so now we need to create a variable that will contain or it'll be kind of treated like a grid. So what we can do this is by using 2D arrays. If you remember in the slideshow, in episode 1, there is a slide on there that described the use of 2D arrays for our tile objects. So what we can do is actually just declare this. And the way you declare 2D arrays is if we do tile, we use these 2 square brackets. I'll put the name of this first. Then we got board. So it's actually just created a 1D array. And to make it 2D, we actually want to put a comma in the square brackets here, and this will go ahead and create us a 2D array. There's also a jagged array if you do 2 square brackets like that, but we're not going to worry about that, as a 2D array fits our needs more than a jagged array. So anyways, what we're going to do now is we're going to create our tiles. So we're actually going to use a method for this. We're going to do public void create tiles, int width, int height, and then int mine amount. And so you might be wondering, oh, well, why are we adding parameters for this? And that's what these are, by the way. If you add variables into the parentheses of a method, it basically allows you to pass in values. What we're going to be doing is we're actually going to be assigning what these values are to these values, so we can use it later. This is just for simplicity's sake, so we aren't using two different kinds of variables that hold the same value. And the reason I'm doing this is because I intend to have an input field where you can actually put the width, the height, and the mine amount, so it can be customized every time the user wants to start a game. And first thing I want to do as well is to create a start method, and the start method is called right as the game starts, or before the first frame is called. And so I want to call the create tiles method, and I'll just pass in the default 10, 10, 10. So now we want to override our private variables up here, so we'll just go ahead and type in all this. It's actually giving me the suggestions as I go, which is very handy. Oops. There we go. And now we actually want to create a, well, it's giving me the thing right there. But we actually want to initialize our 2D array before we do anything with it. Otherwise, it'll throw us an error saying that the index out of bounds or something along those lines. So we actually want to do board equals new tile. You can see it's giving me the suggestion right there. We're going to do new tile and then the width and height. So this is basically creating a grid of the size, width, and height. So you can imagine just a 2D grid of those tiles that we had of this size. Alright, so next thing we're going to do, we actually want to create a tile size variable that'll keep I'll be the container for the size of the tiles. So if you remember, if we go to our tile prefab, you can see the scale up here. I mean, they're all the same, so we can just access the X, Y, or Z, and we can just store that in a variable. So we know how much to space these tiles apart. So you can see here we have 0, 0, and then if we look at the tile above, it's actually higher than it by 0.4 because of the scale. So this will be handy for us if we to instantiate tiles uniformly so they aren't intersecting each other in any fashion. So to do that, we want to create a local variable, which a local variable is only accessible in the scope of this method, and that's what these are. And that's the same thing with these up here, the parameters that we have up here. These are only accessible within the scope of this method. So our tile size is going to be the tile, which is our prefab. We're going to get the transform its scale, and then we'll just get the x value since all three axes are of the same size. So now, next thing we want to do, we actually want to create a nested loop, so we can loop through every single value, or rather location in our grid, or 2D array, rather. So to do this, we're going to do for int, and then we need our first iteration for to have this make more sense. We'll use x, and we'll have x less than width, and for int y equals 0, we'll have this less than height. So basically, actually, I think it'd be better explained once we actually start assigning things to our 2D array. But basically, you can think of these as, or the x's as columns, and the y as rows. And the way we actually want to access a 2D array is we want to first references. I think you can see it's going to be a suggestion right here. This is actually how you would access an element of a 2D array. It would be your first value and then comma and your y value. So this is a column and rows, and then you can do equals. And since this is a 2D array of tiles, we can only assign tile objects to this, which we'll worry about that in a second. So I'll just comment that out for now. Okay, so now before we assign anything to a 2D array, we actually have to create the object before we do anything else. So we actually want to do game object, and I'll name it new tile. And then we're actually going to use the instantiate method. That's inside Unity, and this allows us to clone objects. And you can see here it clones the object original and returns the clone. There's a bunch of other overloads here, but we're not going to worry about that. We just want to clone the prefab. So we can do instantiate and then tile. We can put our tile prefab in there, and this will actually create a clone of our prefab, and we can now use that. And for more organizational sake, I don't want these new objects just cluttering the hierarchy, so I'm just going to set its parent of this new object to our board. So we'll do this. So a new tile, transform, set parent to transform. So what this will do is that this will set every instantiated prefab to be a child of this. So now that we have that done, we actually want to assign our new tile to the board for later access. So we can do this by getting our new tile and then getting the component of tile from it. Since this only takes tile instead of game objects. And we can actually run this now, and we can see if we do run this, you see that actually is instantiating these objects. Actually, I think it'd be better if I just save all these currently. So if we run, you'll see that we have just a tile in one place, and the reason for this is because we actually haven't changed the position of our tile. We actually have to let the compiler know, or rather Unity know, that we want to separate these tiles off by increments, because obviously a grid is going to be in a kind of a square fashion or rectangle fashion, however you have the width and height set, and we want to instantiate the tiles in that pattern. So the way we can do that is by changing the transform, obviously. So we're going to do new tile the position is equal to new vector 2. And then what we can do here is, remember our tile size, we can actually multiply, if we get our y, so our current iteration that we're at, we can actually multiply this by the tile size. Whoops. If we do that, you'll see that if we go back into our scene here, if I save, you'll see that it's actually created a grid of tiles for us, and that's very handy, very cool to look at. But one thing you might notice is that it's actually creating these objects around an arbitrary center point. It's not actually building around the center of the screen, since the pivot here, or at least where the first tile is instantiated, is at 0, 0. So how can we make it so these are being built around the center of the screen? So a way we can do this is a little bit of math. So for more visualization purposes, I'm going to create a game object here. Oops, accidentally undid it. And you'll see, you might notice that the center point looks like it's going to be around maybe about around here. But we can actually determine this exactly. Because if you remember that, this is 10 by 10, and each tile size is 0.4 due to the scale. If you actually get the x position, so if we do 0.4 times 10, and you can actually do math in the inspector here, if you just do that. And if we divide it by 2, you'll see, well, it's kind of in the center, but not quite. It's actually around the center of one of the tile objects. You might notice, well, hey, this looks like it's half of, if we subtract it by half of the tile size, which if we do that, since it's 0.4, just is subtracted by 0.2, since 0.4 divided by 2 is 0.2. You'll see that we actually have our little game object here dead in the center, at least for the x value of our grid. And we can actually do this same thing for the y position. So if we do 0.4 times 10, and if we divide that by 2 again, subtract minus 0.2, you'll see we actually get the exact center of what our grid would be. And you can see that the supposed center of our grid would be 1.8 and 1.8. And obviously this will vary if you have different sizes of height, width, and all that. But we'll make it so it accounts for all those. So what we can do with this information is, what if we actually subtract all of these tiles positions by this? And this will actually shift all of these into the center of the screen. So if we actually go ahead and apply this to our script here, we actually need to make this. We actually need to calculate the center first, and we can actually do this before we even do anything here. So we'll create a vector 2 center, and so if you remember the math operations we did, we multiplied the tile size by the width, at least for the x. So if we take our width and multiply it by the tile size, and remember that we divided it by 2, this will give us that point that's kind of close to the center, but it's not exactly, because we actually need to move it to the left a little bit by half of the tile size. So now if we subtract this by the tile size divided by 2, oops. And if we put these in parentheses for just easier readability, and so it actually performs the operations in the correct order. And we also have to do this for the y value as well. So we can actually follow this exact same format, but instead, let's see, I want to take the height instead. And now that we have our center value, and we actually want to come down here to where we're assigning the position, and just subtract by the appropriate value. And then for the sake of reading it easily in the inspector, I'm actually going to set the name of each of these tiles to its appropriate coordinate. So if you do a $sign and then before 2 quotation marks, by the way, this is a string, just a sequence of letters, so you can just put in anything you want in here. But I actually want to put in the x and y value into this name here. So if I put a $sign, I can actually use curly brackets and put any value that I want in here. So for this, I'll be putting the x and y. So that's a little handy formatting trick rather than putting plus signs to concatenate repeatedly. So if we actually save this and run, we'll see. Make sure all those are disabled. Well, look at that. It spawns in the center of the screen. And if we actually check if this works with other sizes, say we want 5 by 15 or something, we'll see that this will actually work with a variety of sizes, depending on what the player inputs. You can see, oh, well, we got a 5 by 15 board. We can see that, yeah, looks like it's in the center to me. So that's kind of the whole gist of instantiating our tiles. And since we have a board now, we'll actually have to worry about what we can actually do with that board. And obviously, we want the player to interact with all of those tiles. So say we click on those tiles, we want to reveal that tile to the player, which we'll worry about in the next episode, since this is kind of a big chunk of information, and I like you to digest that pretty easily.